Slide 1 title. Hello, investors. Today, we delve into the technology behind the scenes that defines the performance of AI semiconductors. You've heard the news about the shortage of NVIDIA GPUs. But did you know that the bottleneck isn't the GPU chip itself, but a specific manufacturing process? That process is advanced packaging, specifically TSMC's CoWoS technology. With Moore's law reaching its limits, the main battlefield of semiconductors has shifted from miniaturization to packaging. In this video, I will explain why. The back-end process is the hottest investment theme right now, and how specific material manufacturers are winning in this space. Slide 2. The end of Moore's law. First, let's understand the physical wall we have hit. For decades, the industry improved performance by shrinking circuits known as Moore's law. But as we reach the atomic level of a few nanometers, further shrinking is becoming technically and financially impossible. The new logic is, if we can't make it smaller, let's connect them better. Advanced packaging was born from this shift. It involves packing multiple chips into a single powerful package. In the AI era, how chips are connected is now more important than the performance of a single chip. Slide 3, the CoWoS impact. Enter the technology physically supporting the current AI bubble. TSMC's CoWoS chip-on-wafer-on-substrate. How is it different from traditional packaging? The key is the silicon interposer. It places the GPU and high-bandwidth memory, HBM, side by side on a special silicon bridge, extremely close together. By connecting them with microscopic wiring, it achieves overwhelming data transfer speeds. The world's most powerful AI chips like NVIDIA's H100 and Blackwell simply cannot function without this CoWoS technology. Slide 4. The real bottleneck. Why is there a global shortage of AI chips? The answer is simple. TSMC simply doesn't have enough CoWoS production capacity. This process is incredibly complex and precise. You can't just build new factories overnight. No matter how many GPUs NVIDIA wants to make, if TSMC can't package them using CoWoS, they cannot be shipped as products. This back-end process literally holds the power of life and death over the AI market. Slide 5, chiplets and UCI. Furthermore, this technology has birthed a new trend called chiplets. Instead of manufacturing one giant chip, companies make smaller functional blocks, chiplets, and assemble them like Lego bricks. This improves yield rates and reduces costs. Intel and AMD are aggressively pushing this strategy. With the UCI standard, a future where chips from different manufacturers connect seamlessly is just around the corner. Slide 6, the supply chain winners. This is the most critical part for investors. Who is supporting the evolution of advanced packaging? It is largely Japanese companies. The back end is a battle of materials and equipment. For example, in IC package substrates, companies like Ibiden and Shinko Electric Industries hold top global shares. Consider Disco, whose cutting equipment is essential for grinding and stacking multiple chips, or Resonac, which provides the critical insulating materials. To connect these chips, the more advanced technologies like CoWoS become, the more indispensable these high-quality materials and equipment become. Slide 7, next-gen glass substrates. But technology doesn't stop. The next big wave after CoWoS is glass substrates. Replacing current resin substrates with glass allows for flatter surfaces, better heat resistance, and finer wiring. Intel is leading this charge, aiming for mass production in the late 2020s. If glass becomes the standard, companies with strong glass processing technologies like Hoya or AGC will face a massive opportunity. Slide 8. The rivals. Rivals are desperate not to let TSMC dominate alone. Samsung is fighting back with its iCube technology, leveraging its strength as a memory manufacturer. Intel is pushing its Foveros 3D stacking technology as a pillar of its foundry business. Superior packaging technology has become the deciding factor in the foundry wars. Slide 9, the future, hybrid bonding. Looking further ahead, a revolutionary technology called hybrid bonding awaits. This technology connects copper electrodes directly without using solder bumps. This causes connection density to skyrocket. It is no longer just placing chips side by side, but evolving to a level where chips merge into one. This is the key to boosting AI computing power by multiples in the coming years. Slide 10. Conclusion and strategy. In conclusion, in semiconductor investing, you can no longer win by just looking at the front-end miniaturization. For the next decade, the source of value will shift to the back-end packaging. Look beyond the main actors like NVIDIA and TSMC to the stagehands supporting them, material makers like Ibiden, Disco, Resonac, and Ajinomoto Fine Techno. As long as AI continues to evolve, the demand for their technology will not disappear. From the era of shrinking to the era of connecting, riding this wave is the smartest investment strategy.